In this online session, we are going to discuss how to analyze a flow process. As we discussed in the face-to-face session, a flow process typically involves multiple activities, and these activities have to be performed in sequence. So let's look at this example. This is a DMV example. So you go to DMV to renew driver license. So these are all the activities you have to do. So here, this particular example involves 6 different activities, 1, 2, 3, 4, 5, 6. And the table also shows the cycle time for each activity in seconds. So for example, the first activity is review application for correctness. So it takes about 15 seconds. The last one is about issue temporary driver license. It takes about 30 seconds. So this is cycle time, how long it takes to process each activity. So this is just copy paste. Now first of all, let's draw a flow chart to describe the process. So here, when we draw a flow chart, we're going to show some information in each box. So we use each rectangle to represent one activity. So here we divide the rectangle into small 3 spaces. The upper left part, we use the upper left part to represent activity numbers 1, 2, 3, 4, 5, 6. The lower part, we want to represent a cycle time. And the right part, we use for capacity. So we divide the rectangle into 3 parts and use different parts to show different pieces of information. So this is a flow chart. So because here I have 6 different activities, that's why I have 6 rectangles. So 1, 2, 3, 4, 5, 6, and it also shows the sequence. We use an arrow to connect these activities, these rectangles, because the flow process has a sequence. The arrow shows the sequence. So you have to do 1 first, then do 2, and do 3, and the last activity we perform is activity 6. So this is a flow chart. This is a very simple version of flow chart. Next, in each rectangle, we are going to show some information. As I said, the upper left part, we use the upper left part to show the activity number. That's why you see 1, 2, 3, 4, 5, 6. And then we use the lower part to show the cycle time. So for example, for activity 1, the cycle time is 15 seconds. So we just type 15. So 15 seconds, that means the cycle time for activity 1 is 15 minutes or 15 seconds. And then we use the right part to show the capacity. So as we discussed in the face-to-face session, we say cycle time and capacity are interchangeable. So if we know the cycle time, we can calculate the capacity. So how do I calculate capacity based on cycle time? So capacity is equal to 1 over cycle time, or 1 divided by cycle time. So that's the formula. So here, cycle time 15 seconds. So given the cycle time 15 seconds, let's calculate what is the corresponding capacity for activity 1. So we can do the calculation. So capacity is 1 over CT. CT means cycle time. So what is cycle time here? 15 seconds. So one thing we typically do for analyzing flow process in service industries, most times when we talk about capacity, we talk about capacity in terms of capacity per hour. The time unit, we commonly use time units hours. So that's why here, the cycle time in this particular example is 15 seconds. We want to convert 15 seconds to hours. Okay, to be consistent, we want to, because eventually we want to get the capacity. We want a capacity in terms of capacity per hour. So that's why we want to convert cycle time to hours as well. So 15 seconds is equivalent to how many hours? So we know 1 hour is equal to 3,600 seconds. So that's why 15 seconds can be converted to 15 divided by 3,600 hours. So this is equivalent. So 15 seconds is equivalent to 15 divided by 3600 hours. So we convert this to hours. Then we can do the math. So 1 over, there are two divisions. So 1 over 15 over 3600, which is the same as 3600 divided by 15. So if you do the math, you will get 240. So how do we interpret 240? So 240 can be interpreted as capacity, 240 per hour. That means you can do 240 units of work per hour. So that's a capacity. Then we can write down the capacity in the right part. So 240 is the capacity. Similarly, we can do this for activity 2. So for activity 2, so cycle time 30 seconds. So based on the cycle time 30 seconds, we can convert it to capacity. So capacity is 1 over cycle time, so 1 over 30 seconds. 30 seconds convert to hour. So 30 divided by 3600. So this is how many hours. Then we can do the math. This is equivalent as 3600 divided by 30, you have 120 per hour. So we write down 120 per hour here. This is the capacity. So we can do this for the rest of activities. For activity 3, cycle time 60 seconds. We can do the math. We calculate the capacity. The capacity is 60 per hour. For activity 4, cycle time is 40 seconds. Then we can calculate capacity. Capacity is 90 per hour. For activity 5, cycle time is 20 seconds. That's why the capacity is 180 per hour. The last activity, activity 6, cycle time 30 seconds. The capacity is 120 per hour. So now we're pretty much done with the flow chart. So we draw a flow chart and we write down some key information. So the 2 pieces of information we write down, the cycle time and the capacity. The next question is once we have this flow chart, we want to figure out what is the capacity for the entire process. So now we know the capacity for each activity. For example, the capacity for activity 1 is 240. Capacity for activity 2 is 120. So now the question is what is that capacity for the entire process? Not for any individual activity. What is the capacity for the entire process? To identify the capacity for the entire process, we need to identify the bottleneck activity. As we discussed in class, the bottleneck determines the capacity for the entire process. So the capacity for the entire process is the same as the capacity of the bottleneck activity. So what is a bottleneck activity? So as we discussed, the bottleneck activity is the activity that has the smallest capacity. So if you look at all these 6 different capacities, the 240, 120, 60, 90, 180, 120, which number is the smallest? So we know this number is smallest. So activity 3 has the smallest capacity or the longest cycle time. So when a capacity has the longest cycle time or the smallest capacity, we say this activity is a bottleneck. So that's why this is a bottleneck activity. So now we know activity 3 is a bottleneck activity. So that's why the capacity for the entire process is equal to the capacity of activity 3. So that's why the capacity for the entire process is 60. So bottleneck activity is activity 3, system capacity is 60 per hour, system cycle time is 60 seconds. Because everything, the system capacity, system cycle time, depend on the bottleneck. It's the same as capacity and cycle time of the bottleneck activity. So that is how we analyze a flow process. Basically, draw a flow chart first. Then you write down 2 pieces of key information, cycle time and the capacity. Then you try to identify the bottleneck. Then you try to figure out what is the capacity or cycle time for the entire process, or system capacity, system cycle time. Next question is, if you look at the flow chart, let's say if we can double the capacity, if we add 1 more person to handle activity 3. So now we know activity 3 is slowest one, has the smallest capacity. So this one, activity 3, will block the entire process. So how do we improve it? So one natural strategy to improve the whole process is to add more workers to increase the capacity for activity 3. By increasing the capacity of activity 3, we can increase the capacity for the entire process. So now the question is, what if we add one more person to handle activity 3? So if we can add one more person to handle activity 3, that means we can double the capacity for activity 3. So right now, the capacity is 60. With one person, the capacity is 60. What about with two persons? If you have two persons handle activity 3, the capacity will be doubled, will be 120. My question is, does that mean if we hire one more person to handle activity 3, does that mean the system capacity or the capacity for the entire process can be doubled? Think about it. The answer is no. Okay, the answer is no. By adding one more person to increase the capacity for activity 3, we can double the capacity for activity 3. However, we may not be able to double the capacity for the entire process. If you take a look at this, if we double the capacity, make it 120, if that's the case, we will see a new bottleneck activity. The new bottleneck activity becomes activity 4. It becomes 90. I have 120, 180. If we double this one, make it 120, and this one will become the smallest one. Okay, so this will become the new bottleneck. So by adding one more person to handle activity 3, we don't really double the capacity for the whole process. Instead, activity 4 becomes a new bottleneck, and the new capacity for the entire process will become 90 instead of 120. So that is the first example. Next question is, can we do better? Okay, can we do better? If we are allowed to hire one more person, is there any way we can double the capacity for the entire process? So make it 120. So right now it's 60. How can we make it 120? If you only add one more person to handle activity 3, we can only increase the system capacity to 90, not 120. The question is, can we do better? Is it possible to make it 120? The answer is yes, but we have to restructure it. Okay, we have to restructure it. We have to restructure the process by grouping activities together. So this is what I want to do. So what if we group activities 1 and 4 into a single activity, let one person handle it? So in the past, each person handles one activity only. So now with a new process, so we're going to group activity 1 and 4 into a single activity, let one person handle it. Same time, we're going to schedule 2 clerks to perform 1 and 4, perform the new activity, and we'll also schedule 2 people to perform activity 3. So this is how it looks like. So in the past, because we had 6 activities, we hired 6 persons. Now we are allowed to hire one more person. We have 7 persons to do the work. So this is a flow chart. So we're going to group 1 and 4 together, but we have 2 people. So we have 2 boxes, 2 rectangles. Each rectangle represents 1 person. So I have 1 person, another person. So 2 persons handle the new activity. Same time, we have 2 persons to handle new activity 3. Then 2, 5, 6 will stay the same. Okay, so all together you can see 1, 2, 3, 4, 5, 6, 7. We have 7 people. We basically hired 1 more person. Now let's analyze this process. First of all, let's look at activity 1 and 4, the new activity 1 and 4. So by grouping 1 and 4 together, so there's 1 person handles 1 and 4 together. So that means what? That means the cycle time will be longer. It takes longer to complete job activity 1 and 4. So it takes longer. So how much longer? So it takes about 15 seconds to do 1 and takes 40 seconds to do 4. So that's why if you combine 1 and 4, the new cycle time becomes 55. So 15 plus 40, 55. So with the new cycle time, of course, the capacity will be different. So how do we calculate capacity? It's 1 over cycle time. So 1 over 55, convert 55 seconds to 55 divided by 3,600 hours. So you have 65 per hour. So that's the new capacity. So the new capacity is 65 per hour, but we have 2 people to handle it. Similarly, for activity 3, the cycle time is 60. We don't have to do any new calculations, the same. And cycle capacity is 60 per hour. For activity 2, 5, 6 will stay the same. Okay, the cycle time capacity will stay the same. You can copy paste from the previous slide. So this is a new flow chart. Now we have to identify the bottleneck activity as well as capacity for the entire process for this new configuration. Some people don't know how to handle it because why? You see, I have 2 people here. I have 2 people here. It looks unfamiliar, right? Two people here, not very clear. So before we identify the bottleneck for the new process, what we can do is we don't like this. We don't like 2 parallel persons. We don't like 2 boxes. So we can convert these 2 boxes into a single box to make it clear. So basically, we want to convert this into the yellow box. So that means what? We want to do some transformation and make this equivalent to this. Okay, equivalent to this. So the activity number same as 1 and 4. We do 1 and 4 together. I have 2 people to handle it. Okay, cycle time 55, capacity 65. So I converted this into a single box, make them equivalent. Think about it. If you have 1 person to handle it, the cycle time is 55. It takes 55 seconds to handle 1 activity, the new activity, 1 and 4. Now we have 2 people. If you have 2 people, that means it's faster. Okay, that means it's faster. Faster means what? Faster means the cycle time will be shorter and the capacity will be larger. And so how do we convert? So the capacity was 55 because I have 2 people to handle it. The cycle time will be faster. So what's the new cycle time? Divided by 2 because I have 2 people. So it's faster. Faster means that shorter cycle time as we discussed in class. So 55 divided by 2, 27.5. So that is the new cycle time. Similarly, with 1 person, the capacity is 65, but I have 2 people. With 2 people, my capacity can be doubled. So the new capacity is 65 times 2. Why 2? Because 2 people. 65 times 2, so 130. So that is the new capacity. So if you look at these 2 boxes versus this 1 single box, they are equivalent. Okay, they are equivalent. Similarly, we can convert these 2 rectangles into a single rectangle. It's activity 3. The cycle time was 60. I have 2 people. That means the new cycle time, 60 divided by 2, it's 30, it's faster. The capacity was 60. I have 2 people. So the new capacity is 60 times 2, 2 people. So I have 120. So now I convert these 2 boxes into a single box for the first 2 stages. So now let's look at the new flow chart. So I have 5 different stages, 1 and 4, and then 3, then 2, then 5, and then 6. Look at these 5 boxes, okay? You can skip this area. Look at these 5 boxes. Now let's try to identify the bottleneck activity. So let's look at 5 different stages. The capacity for the first stage, 130. Capacity for the second stage, 120. And then 120, 180, 120. So we want to identify the bottleneck. The bottleneck means the activity that has smallest capacity. So which one has the smallest capacity? So if you look at these 5 numbers, it's 120. So that means these 3 activities are the bottleneck activities. So it's not a 1 stage. I have 3 stages. I have 3 activities. They have the same amount of capacity. So all of these 3 activities are bottleneck activities. So the bottleneck activities 2, 3, and 6. Okay, 2, 3, and 6. They are all bottleneck because they have the same capacity. So system capacity is equal to the capacity for the bottleneck activity, which is 120 per hour. System cycle time is equal to the cycle time of the bottleneck activity, so which is 30. It's 30 seconds. So that is second configuration. So by doing this, we hire one more person, and same time we regroup activities. We have a new configuration. We can double the capacity. It was in the previous slide, if you recall, in the previous slide, it was 60 per hour. Now we have 120 per hour. So we did a few things. We did hire one more person. Same time, we structure the process. Is this the only way we can do? Is this the only way we can do? The answer is not. Okay, there are other ways we can do it. So what if we group activities 1 to 5 into single activity? Same time, we schedule 6 clerks to perform the new activity and schedule 1 clerk to perform activity 6. What does that mean? This can be another configuration. It can achieve the same purpose. So what we want to do is we have 6, 7 people. As we said, we're going to hire one more person. So we'll have 7 people to do the work. So we group activities 1 to 5 into a new activity and schedule 6 people to do it. 1, 2, 3, 4, 5, 6 people to do it. Then we let one person to handle activity 6 separately. So this can be new configuration. Okay, so this configuration, as you can see later, we can double the capacity as well. So let's do the analysis. So by grouping activities 1 to 5, the cycle time will be different. So what will be the new cycle time? We simply add the cycle time for all these 5 activities, 15 plus 30 plus 60 plus 40 plus 20. So we have 165. So the new cycle time is 165 for the new activity because it takes longer. We have this person has to handle 5 activities at the same time. So with the new cycle time, we also can calculate the capacity. The capacity is 1 over cycle time is 1 over 65 seconds. As we said, we want capacity to be the capacity per hour. So we want to convert 160 seconds to how many hours? So 165 divided by 3,600 hour. You do the math, which is that 3,600 divided by 165, you have 22 per hour. So the capacity will be 22 per hour. Okay. So that is the new activity. For activity 6, it's the same. Cycle time 30 seconds and capacity 120 per hour. So next we can convert these six boxes into a single box. Yeah, into a single box. So activity 1 to 5. For each box, the cycle time is 165. Because we have 6 people to handle the same job, we can do things much faster. So what is a new cycle time? The new cycle time is 165 divided by 6. Why 6? I have 6 people. Okay, divided by 6. So 27.5. It's much faster. So with 6 people performing the same job, it's much faster. That's why cycle time will be shorter. Similarly, what's a new capacity? The capacity was 22. Now, because I have 6 people to handle it, that means my capacity will be much larger. So it'll be 22 times 6. We have 132 per hour. So that is the new capacity. This is the new cycle time. So with these 2 boxes, now the new activity, new flow process only includes 2 stages, stage 1 and stage 2. Now let's identify the bottleneck. You can see the bottleneck is pretty straightforward. Bottleneck activity is activity 6, because activity 6 has a capacity 120 as compared to the new activity 132. So this is a bottleneck. So system capacity is 120 per hour. System cycle time 30 seconds. Bottleneck. Bottleneck activity 6. So what's the benefit? So this type of configuration has some benefit. Think about DNV. First of all, there's no need for customer to wait in between process. If you think about the original configuration, each activity is handled by one person. So there are multiple lines customer have to join. But now with the new configuration, we only let one person, one clerk handle activities 1 all the way to 5. So customer don't have to wait because everything is done by the same person. And total time shortened as no information needs to be passed between process. Well, that's pretty straightforward because one person handles everything, no need to pass information. So no communication needed. The last one is labor cost can be saved when dealing with varying demand. If you look at configuration, it's a parallel process, So what's the benefit about parallel process? The benefit is it's more flexible. So when the demand is really, really high, if you see a lot of customers, we can schedule a lot of people here. We can schedule more people. But when the demand goes down, okay, during off-peak period, we can schedule fewer people, so we can save the labor cost. So that is a major benefit.